All right, so now that we've learned our power rule, which is the most basic derivative rule, but the most commonly used, we're going to introduce the product rule. Okay, so we mentioned before how if you're adding or subtracting two functions, you can just add and subtract their derivatives, right? Each function can be considered separate and just use whatever rule necessary. When you have a product, however, you cannot just take the product of the derivatives. That's not going to work. All right, it's never going to give you the correct derivative. So we have a product rule to use. So we're going to show it using our u and v notation, and then we'll show it using function notation. Okay, so our product rule with derivatives. This is the notation that I'm going to use a lot when I'm talking about product rule, but we're going to also show the function notation. So it says let u and v be two functions of x. And this is something we use a lot in calculus rather than calling it f of x and g of x, just because it's a little quicker. But keep in mind that u and v are not necessarily variables. They represent two different functions of x. All right. So if you're trying to take the derivative with respect to x of the product of the two functions, then we say that that equals u dv plus v du. All right. So what that means is that u is that first function, so you just keep it as it is. dv would be the derivative of v. Technically, you would write it as dv dx, but this is just the shorthand notation for it when we say it quickly. Plus, then we keep the v function as it is and multiply that v function times the derivative of the u function. So again, this is really du dx, but we just kind of say the shorthand for u dv plus v du, all right, because you'll say it a lot in your head when you're using your product rule. The way you would write it using function notation, it's the same rule, but it would look like this. So instead of using u and v, we've got f of x and g of x, just showing that these are two functions of x. They're not coefficients or numbers. All right, that technically wouldn't be a function of x, that would be a constant. So keep that in mind. If f of x or g of x is just a number, then you just use your coefficient rule. You don't use product rule. Okay, but this is really saying the same thing. So you do the first function times the derivative of the second, plus the second function times the derivative of the first. And since this is multiplication and this is addition, this rule is commutative. So if you switch u and v, it's not going to give you a different derivative because you're just adding these two functions. It just means that this one would come first and this function would come second. So with multiplication, it's commutative, so it doesn't matter which function you call u and which one you call v. I just am in the habit of picking the first function as u and the second one as v. Okay, so let's do some examples where we need to use product rule, and let's look at some where maybe we don't. Okay, so this says to find the derivative of h of x. And h of x is defined to be x cubed times cosine x minus 2 sine x. Sometimes I like to say the function out loud so I know which rule I'm going to use. So when I say x cubed times cosine x, that is a product. And then minus 2 sine x. The 2, even though there's a multiplication here, since the 2 is just a number, it's not technically a function of x, we don't need to use product rule there. All right, so the first term is a product of two functions of x. We're going to use the product rule, but the second term is just a single function of x with a coefficient. Therefore, we do not use the product rule. Okay, so the first thing I like to usually do is just kind of put a little u and a v up above each function. So when I'm doing my rule, all right, I know which function's u and which function's v. You can write it off to the side as well if you like. So our derivative, h prime of x, is going to equal, and I like to start off using all parentheses so we can see our four products. So u is x cubed, dv, so the derivative of cosine x. We did that the other day. That was one of our basic rules. The derivative of cosine x is negative sine x. And this is where you really want to have the parentheses, because if the parentheses aren't here, this looks like it would be like, it looks like it would be a subtraction rather than a multiplication. All right, so always start with the parentheses and then we can simplify at the end. So u dv plus v, which is just our cosine x, du. And that one we have to use our power rule. Derivative of x to the third is 3x squared. And this is what I mean by power rule being essential, because it's used within a lot of other rules as well. And then don't forget, we still have this term on the end, minus 2 sine x. The minus 2 just goes along for the ride, and you just take the derivative of sine x, which is cosine x. So that gives us minus 2 cosine x. And then we're just going to write our simplified answer. I like to put all the coefficients out in front and then the trig functions at the end. So the negative we're going to move out in front to get negative x cubed sine x. The 3x squared does not get multiplied by this x. This x is inside the cosine function, so it's untouchable. The 3x squared, we're just going to put it out in front. And then we have the cosine x, and then minus 2 cosine x. And there's no like terms to combine. There's nothing we can factor out. We would just leave it like this. Remember, as long as you have a correct derivative, that's okay. The only time you have to write it in a specific form is if you're trying to use it for something, or if you're trying to do a multiple choice question and match up your answer to one of the ones given. All right. So don't try to simplify if you don't have to. Okay, so let's look at the next example. So for this one, again, find the derivative of y equals 3x minus 2x squared times 7 plus 4x. So again, this is a product of two functions of x. However, this function could be rewritten as the sum and difference of powers if we decide to FOIL. All right. So this is something we talked about, rewriting functions, because power rule is our easiest rule. So if it's easy to simplify the function using those algebraic techniques, right, we can do that first, which I would do because FOILing is pretty easy, and then I just have to do power rule. If you did product rule, it would still work, all right, but I would just find it easier to use power rule if possible. So when we FOIL, we get y equals 21x plus 12x squared minus 14x squared minus 8x cubed, and we can combine like terms before we take the derivative. That will give us 21x minus 2x squared minus 8x cubed. And now we're going to do our power rule here. So now since these functions are just being added and subtracted, we can just do the power rule on each one. Our derivative ends up being 21 minus 4x minus 24x squared. Okay. And we can leave it like this. We don't have to factor it or do anything special to it. We can just leave it as y prime equals. All right, so let's take a look at another example. So now this one's asking us to find the second derivative. We haven't really talked about second derivatives, but all that means is that you're going to find the first derivative and then take the derivative of the first derivative. All right, that's how you get a second derivative. You can find third derivatives, fourth derivatives, and so on. Those are what we call higher order derivatives. Okay, so that's something that you can write down. Any derivative over the first derivative, second, third, fourth, are called higher order derivatives. Okay, so looking at this function, there's no way to simplify this function or to rewrite it, so we have to do product rule, x times cosine x. So we have to pick our u and our v. So I'm just going to put a u above here and a v here, and we're going to do our product rule, u dv plus v du. So using our parentheses, y prime equals u dv, derivative of cosine x is negative sine x, plus v du would just be 1. And then we can simplify by getting rid of the parentheses, put all of our coefficients out in front, so the negative moves out in front with this x. Remember, you do not multiply these two x's together. This one is inside the sine function, this one is not. So it just stays out in front. So negative x sine x plus cosine x. So now this is our simplified first derivative. We want to take the derivative of this. So negative x sine x, that's going to have to be a product rule. And then cosine x, we'll just take the derivative of at the end. So again, we're going to identify our u and our v and do our u dv plus v du. And then don't forget to take the derivative of plus cosine x, which will be minus sine x. So here's our, oops, actually this should say the notation here. I made a mistake here. This notation should say y double prime. There should be another prime right next to here. All right, so that was my mistake. There should be another little prime symbol right next to this one. That's how you know it's the second derivative. Okay, so just make sure you correct that. So u dv, all right, plus v du would be negative 1. And then we've got our minus sine x. So when we simplify our first term, we just get negative x cosine x. Here, this becomes minus sine x, and we can combine those two like terms to get minus 2 sine x. So again, y double prime should be written here. So just make that correction. Okay, and then the last thing we can do is we can also incorporate the use of tangent lines when using product rule. So let's say we're asked to find the equation of the tangent line to the function f of x equals 2x times the natural log of x to the fifth when x is 1. So the second I see equation of the tangent line, I want to think point and slope. All right, so we need to find the point and we need to find the slope. So they gave us half the point. They gave us x equals 1. To find the point of tangency, you just have to plug 1 into the original function. So f of 1 would equal 2 times 1 times the ln of 1 to the fifth, which is just 1. And we need to know how to evaluate the natural log of 1. So when we evaluated logs at the beginning of the year, okay, remember, logs equal exponents. So this is log base e. So what's the exponent of e to get 1? That would have to be 0, right? E to the 0 equals 1. So ln of 1 is 0, and 0 times anything will be 0. So there is our point of tangency, 1, 0. So now we need to find the slope. So to find the slope, we need to take the derivative of f of x. So looking at this would be a product rule, but remember, if you can simplify this original function, you want to do that first, which we can do because we have the log of a power. All right, so remember with our log, we have our expansion rules. The log of a power, you can take this 5 and move it out in front, multiply it out in front, and that would give us 10x ln of x. So this is still f of x. We haven't taken the derivative yet. We just simplified it a little because, again, we don't know how to take the derivative of ln of x to the 5th. We only know the derivative of ln of x. But again, this is still a product, so we have to use our product rule. So I'm going to let u equal the 10x and let v be the ln of x. And we're going to do u dv plus v du. So for our derivative, f prime of x, here's our u. dv, the derivative of ln of x, is 1 over x. That's our rule from the first section we did. Plus v, which is just ln of x. du, the derivative of 10x, is just 10. And then we're just going to simplify. So when we multiply these two together, the x's cancel, and we get 10. And then here we're just going to put the 10 out in front. Again, this x is inside the natural log. We don't multiply the 10 to the x. We multiply it out in front. So we get plus 10 ln x. And now to find our slope, we're just going to replace x with 1. So we've got f prime of 1 is going to be 10 plus 10 ln of 1. And we said earlier ln of 1 is 0. So our slope will be 10. And we're just going to use our point slope form. So now that we have our point and our slope, we get y minus 0 equals 10 times x minus 1. And if you want to simplify this into slope-intercept form, you can, but always start with point-slope form. All right, so here, distribute the 10, the 0 goes away, and we get y equals 10x minus 10. So either one of these is fine. Okay, so on the worksheet, you're going to have some derivatives and some applications, and you're going to use product rule when necessary. But we saw in this video that sometimes you can rewrite a function so that you don't have to use product rule. All right, but we have that available to us now if we need it. All right, so